So in this section, we worked on a lot of things, a lot of materials here. We started by understanding what object-oriented programming is, what's an object. Remember, went through the example of car, engine, and what it means to be an object, right, in programming. And so we understood that class is at the center of everything. So a class, of course, contains attributes, properties, or fields, and also behavior and functions. So what a car can do. Okay. We talked about, of course, how to create a class, and then we talked about inheritance and why is that so important to inherit or to have this capability of inheriting from other classes, to have a superclass, the parent class, and the child class, and the importance of all of that. We talk about overriding, of course, and how to design inheritance classes. And then we looked at interfaces as a way for us to separate the main events from the inheritance, meaning we can abstract out, for instance, the click event that can be consumed by any class independent of the inheritance status. It's a really powerful mechanism that allows us to implement certain behaviors individually as a class. And we'll learn, of course, that a function that's created in an interface, it doesn't have a body because it has to be implemented at the class level. And that's the beauty of course, having an interface. And then we jumped into extension functions. It's very powerful because now we can leverage what already is there, because we first talked about leveraging through inheritance. But with extension functions, we can actually use what Kotlin provides, for instance, the string class, and create an extension function that will append, for instance, text to existing string. So that was just one example. And of course, with all of this, I always encourage you to go out and learn more so that you can have a larger pool of knowledge on these topics. But at least, hopefully, this gets you started, okay? And again, we talked about inheritance design steps. One, you have to look for objects that have common attributes. For instance, we see this car, truck, and vehicle as the superclass. And two, you have to design a class that represents the common state and behavior. And three, decide if a subclass needs behaviors, in this case, method implementations, that are specific to that particular subclass type. And of course, we finished with data classes. So if whenever you need a class that just represents or holds data, you don't have to worry too much. Kotlin has such things. So if you say data class and name of that class and pass the property as parameters to our primary constructor, then you should be good. So you've learned a lot of things. Now you understand how to create classes, how to instantiate those classes, how to override methods, how to implement interfaces, and so many things. I hope you're starting to become more curious about this beautiful language and look forward to learning more, either on your own or continue in this course. Now, obviously, there's so much to learning a language that it's virtually impossible to teach that in less than 2 hours, right? Or 3 hours. The whole idea of me putting these sections on Kotlin is to get you started, it's to get you understanding the mechanics of this programming language. So it's time to take a little break, go and relax a little bit before we go on to the next sections.